Hello, hello, and today, welcome to Check to the Costa. We're going to be reviewing our unit on solving problems involving compound interest. So in this unit, we learned to compare the difference between simple and compound interest, and then we related compound interest to exponential growth. And finally, once we understood those things, now we started to solve problems that involve compound interest. And we did that. If you can do all of these things, then you know that you are successful at this unit. If you figured out that compound interest is found by repeatedly calculating simple interest, if you compared simple and compound interest over time, if you determined what is the relationship between compound interest and exponential growth, can you describe what that relationship is? Can you solve problems using a scientific calculator that involve calculating the future value and the present value using the equation, using the formula that you were given? Can you also calculate the total interest earned on an investment or a loan? Can you solve problems using a TVM solver to calculate the interest rate or the number of compounding periods that you need? And finally, did you determine what is the effect of changing the length of time, the interest rate, or the compounding period frequency? How does that affect the future value of a loan? So in our first lesson here, we started talking about what is interest. We got an introduction to compound interest in general. We learned that interest is like a fee for borrowing money, but it could also be used to mean investment profit. We calculate it by multiplying the principal by the interest rate for each year of the term, and that is for simple interest. Simple interest is calculated just on the initial amount that you borrow, the principal, the present value, the amount at the start of your timeline. The formula to calculate the future value of something that is growing with simple interest is given to you here. A equals P plus PRT, where A represents the amount or the future value of the debt, P is the principal or the amount at the start, R is the annual interest rate, so the rate per year, and T is the term, the amount of time in years. Investments in debt grow in value as time passes. If you increase the principal, if you increase the interest rate, or if you increase the term, you can increase the total amount of interest that is paid over the lifetime of this loan or investment. From there, we started to compare it to compound interest. When you add the interest of a loan to the principal to create a new principal, you are compounding the interest. Compounding interest makes the principal grow much faster than simple interest. If you're given an annual interest rate and a term, the compounding frequency, which is the number of periods in 1 year, can be used to calculate the interest rate per period. You take the annual interest rate and divide it by the frequency. And it can also be used to calculate the number of periods in the entire term. So to find that out, you just take the number of years and multiply it by the frequency. Here are some, very commonly used frequencies that you will need to know, right? And what they mean, and how many of these periods are in 1 year. So annually means it compounds every year. There's 1 year in 1 year. Duh. Semi-annually means every 6 months. So if one period is 6 months, how many periods will there be in a whole year? 2. Quarterly is every 3 months, and there's 4 periods, 4 quarters in a year. Monthly is obviously every month. There's 12 months in a year. Weekly every week, and there's 52 weeks in a year. And daily is every day, and there's 365 days in a year. To calculate the total amount of a loan that is growing with compound interest, we came up with this formula, where still P is the principal or present value, I is the interest rate per period, not the annual interest rate, and N is the number of periods, not the number of years. To find the total interest, then we can just take the future value and subtract the principal or the present value, and that'll tell you how much interest existed in that situation. We then learned how to find the interest rate and term. Doing that for simple interest is simple, but for compound interest, we need to use something called a TVM solver. All we do is input the present value as a negative number, the future value as a positive number, and then the number of periods or the interest rate per period, and then make sure the payments are set to 0 since we're not actually making payments every period. That is part of a future concept called annuities. And then whichever one we entered, if we enter the number of periods, you choose the interest rate per period and you click calculate, and it will tell you what is the interest rate. Or you could put in the interest rate and click on the number of periods, and it'll tell you how many periods it'll automatically calculate how many periods that would take. Finally, we looked at what happens to a future value of an investment or a loan if we change these around. So most debts grow by compounding the growth with a principal, and this is the formula for compound interest again, where we know all of the 4 values. But what happens when we change these 3 values, the principal, the interest rate per period, and the number of periods in the term? What happens to the total amount? Well, when borrowing money, what we want is low interest rates, low term, so a low number of periods, a low borrowed amount, and a low compounding frequency, and that will minimize the total amount of interest. The future value will not be very much higher than the principal. But if we're investing money, we want the opposite. We want it to grow really, really, really fast. So we want high interest rates. We want a high number of periods or term. We want a high present value, and we want it to compound very often. And that will maximize the total amount of interest that we earn.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.